Quantum mechanics versus classical reality, the unbridgeable abyss. Modern physics, which describes the world at the quantum level, deals with objects that exist in all possible states at once. This is the principle of superposition. An electron, a photon, or even an atom has no fixed position. Instead, it is described by a wave function containing all its potential properties. But in our classical macroscopic world, we observe only one outcome. The electron was here and not there. The coin landed heads, not tails. This creates a fundamental Copenhagen paradox. At the moment of measurement, or philosophically, observation, the wave function suddenly and inexplicably collapses, leaving only one reality behind. Mathematically, this collapse is arbitrary and non-deterministic, almost like the death of every unrealized possibility encoded in the quantum. And here begins the true intrigue. The role of the observer, the birth of many worlds, MWI. The many worlds interpretation, proposed by Hugh Everett III in 1957, radically rejects the idea of collapse. According to Everett, collapse simply does not exist. Instead of destroying alternative outcomes, the wave function forces reality itself to split. When an observer, a human, a device, or even Schrödinger's cat interacts with a quantum event, the universe divides into parallel independent branches. In one branch, the measuring device detects spin up, and in another, spin down. And most importantly, the observer also duplicates. Your counterpart in the neighboring reality sincerely believes their measurement was the only one, because they cannot access the consciousness of their copy. Thus, every quantum death, collapse, the disappearance of alternatives in the Copenhagen picture, is actually the birth of a new branch of the universe in MWI. The paradox of simultaneity is resolved because all states continue to exist, just in different branches of an infinite multiverse. The philosophical consequences are enormous. Each of our decisions, each interaction, is a bifurcation point generating countless versions of ourselves. Technological aspect, quantum computers and interference between realities. If MWI is true, then quantum computers are not merely tools, they are windows, or more precisely, bridges between these parallel worlds. Quantum computers use qubits in a state of superposition and effectively explore multiple realities at once to solve a problem. Instead of iterating billions of options sequentially like a classical computer, the quantum machine seems to delegate computations to its counterparts in parallel branches of the universe, then gathers the final result through the mechanism of interference. Interference is not merely a mathematical effect. It is evidence that two waves or two realities in MWI intersect and influence each other. In the MWI context, a successful quantum computation may be a temporary merging of information obtained from our parallel copies. It is not teleportation or travel, but informational interaction with neighboring branches of the universe. The technological challenge is maintaining qubit coherence, their connection with one another without collapse or splitting. When a qubit loses coherence, decoherence occurs, and it splits the universe, isolating that computational branch. Thus, decoherence becomes a practical, engineering-level confirmation of new worlds being born, something we struggle to control. Speculative angle, tracing the footprints of other realities. If every quantum event creates a new branch, where are the footprints of these splittings in our own world? How can we prove we are just one version among an infinite multitude? The answer hides in the concept of decoherence. This process describes how a quantum system becomes entangled with its environment instantly turning quantum uncertainty into classical definiteness. Within MWI, decoherence is a wall separating our branch from its neighbors. It records the outcome of our interactions into the microscopic structure of the universe, making any return or merging practically impossible. Speculative hypothesis. Some theoretical physicists propose that the traces of early cosmic branchings might be encoded in the cosmic microwave background, CMB. When the universe was young and structurally simpler, large quantum fluctuations causing branch splits could have left gravitational or temperature imprints on spacetime itself. These imprints might appear as anomalous correlation zones in the CMB, hot or cold spots not explained by standard cosmology. Such a discovery would be a direct paleontological-style evidence of the multiverse. Imagine we are just one cell of an infinite living organism. Every decision carries the paradox of simultaneity, the death of alternatives for our consciousness, but eternal life for those same alternatives in the branching tree of realities. Perhaps this infinite cycle is the true definition of existence. Thank you for watching. See you in the next video.